So let's go ahead and write the method called vowelCount, function I should say called vowelCount. So if I go ahead and run this, it won't work because we haven't defined it, of course. Let's go ahead and define it. Def vowelCount. VowelCount takes a string. This is a string. And we want to count the vowels in it. We want to do it recursively. So you have to think about how you can break down a number, or in this case a string, into something smaller. And in particular, it seems like I could, if I had the vowel count of everything from the first character onward, the vowel count of all the stuff I've highlighted, then I would add into that the vowel count of the first character, right? And so the result would be the sum of those two. So for instance, I have my this count, which is just the first character. It's going to be 1 if s of 0 in AEIOU. So I'll convert it to I'll convert the first character to uppercase and see if it's in this string. I could, by the way, also not convert to upper if you'd rather, and then just go ahead and do this. So then, if it's if the first one's a vowel, I'm going to add that's a count of 1, otherwise 0, and then the rest of my count is recursive, the vowel count for everything else, and therefore my actual count is the count of the first one plus the count of the rest. And it turns out to do this right, you have to spell it right everywhere. All right, so now that's my base case. Nope, that's my recursive case. What is my base case? Well, when we're doing a base case, you have to think about the simplest example. And whatever string we have, we pull off the first character and recurse on the rest. Then we pull off the first character and we recurse on the rest over and over again. It seems like we're done. We run out of characters. And sure enough, when S is the empty string, how many vowels are in the empty string? That's easy. There are no vowels in the empty string. Is this going to work? Look at that. First shot. Beautiful. Okay, so let's go back out here. And you can see in this example, instead of we did use the upper instead of the way we did here with the upper and lowercase in the string. And now we can start getting a little cutesy with this one. So what you do here is you take this expression, this count, and we don't use the variable. By the way, everything from here forward is just being cute. It's really a bad idea to do what I'm doing now. Instead of using rest count, I'll put that in rest count. So now we have, and that still works, although it's getting ugly, right? And finally, I'll put all this in a single return 0 if s is equal to Coco, else this mess. And sure enough, oops, I meant to run that code. And sure enough, that still works, but this is vile. So just because you can write a one-line solution to this function does not mean you should do it. This is a much clearer solution. And it's an okay use of recursion. I believe that the iterative version of this, the one using loops, is every bit as cleaner. But it's a good start. This week we're doing very simple applications of recursion, solving problems recursively that frankly we could have solved just as easily non-recursively. Next week we're going to now take these ideas and push them pretty hard and start solving some problems that frankly fundamentally feel recursive by nature, where there's really no really good way to solve them without recursion, or at least without recursion and explicitly using a stack, which is an idea we have not yet covered anyhow. In any case, that brings vowel count to a close, and in fact it brings these notes to a close.